Thank you very much for the kind introduction. I'm Hiraku Sakamoto. So let me give you our opening remarks for 67th Virtual UNISEC-Global meeting. Again, I'm a chairperson of UNISEC Japan and also a professor at the Institute of Science Tokyo. So today, we have a great lecture by Jerry. I will start talking about my concept experience, concept development experience, because this will give you a very good introduction for systems engineering. I think everybody knows systems engineering is quite important, and I already teach systems engineering to students in UNISEC Japan. And I believe CANSAT, simulated satellite. CANSAT is the best, one of the best material for students to study systems engineering. So I just briefly talk how I teach systems engineering to students in Japan. Okay, so I think many of you know our CANSAT. So originally CANSAT was 300 gram, 350 gram. But recently, especially in Japan, we built a 1 kilogram open class CANSAT. And many Japanese students visit Nevada desert to launch the CANSAT early. And almost 100 students visit Nevada desert. So this is one example. Actually, this example is very old, but this is a typical comeback satellite, comeback CANSAT. We have a paraglider and also we have a crawler. So as the first step, I ask students to define a mission. So basically the sequence, the CANSAT sequence, typical CANSAT sequence is like this. So after the release, this runs back or fly back to the target. So this is a V model of systems engineering. So first, I ask students to design the CANSAT using breadboard model. So left-hand side shows the design and the decomposition, basically. So students make first a visualization of the mission, then making a flowchart to determine the sequence. Then I ask students to clarify the success level, like minimum success, full success, and advanced success. And then students start defining the requirement based on the regulation. Then they decompose the system into system blocks. Then actually this is a prototyping process. So students nobody knows the clear answer from the beginning. So we carry out trial and error. So this is a very repetitive process. Then finally, we integrate the subsystem and the system. Then we carry out end-to-end test by using a breadboard model. So we already reached the right top. Then we, after the breadboard model integration, we returned to the left. So this is a engineering model development process. So by a breadboard model, we already know the left-hand side. So gradually we integrate the engineering model based on the breadboard model design. Then we carry out component model test and subsystem level test, system level test. Then engineering model is fabricated. This is the engineering model development. So engineering model, using engineering model, we carry out many tests, like flight model test, rover model test, and the vibration test, communication test, and end-to-end test. We often use the balloon, and recently we use the drone as well. So finally, we finished the engineering model development. Then For the flight model, we already have a confidence in the engineering model design. So basically, we start the fabrication process for flight model. Then we carry out the test for finding human error, development human error. So we test the subsystem level, system level. Then we go to the R ですね。Nevada desert. So I think by using the system engineering methodology, we can understand this quite complicated or iterative process quite clearly. So I believe system engineering is a quite powerful tool for any aerospace engineers. But I've never thought how I can utilize AI in satellite development very seriously. So today I'm very looking forward to Dr. Jerry Serra's talk. Okay, so this is the end of my opening remarks. Thank you very much.